Yeah.
No, no problem. Okay, absolutely. Yeah, go ahead.
Okay, so my first question is what is your job title?
So I am a partner and owner of the business.
Okay. And you're an architect,
I am a
engineer?
structural engineer.
Oh, okay, okay.
Yep.
And then are you assigned to a project or job site or do you work from an office? It looks like you
Majority,
work from an office.
the vast majority of the time in the office, we do visit the job sites for projects that are under construction, but the majority of the time is spent in the office. Yes.
Okay. And then how long have you been at your company?
Uh, 23 years,
Okay. And then how long have you been working in the construction industry?
31 years.
Okay,
Yep.
cool.
Okay. So for our firm, since we're doing engineering design work, uh, the two programs we use the most are called EnterCalc, and the other one is called RISA. And EnterCalc is a program that basically is where we go in and um, that's where we run kind of the different pieces of a building, beams, columns, walls, for all kinds of different materials. And RISA is more of a modeling program where we can go in and do 2D or 3D models to create, small building frames or small sections of buildings. No, so for us, so EnterCalc is a program where it basically, as the engineer, you're responsible for all the input. So you might, you're gonna to answer your question, no, it's not a program that is dictating like spacing of beams or locations or quantities or anything like that. It's basically it's a fairly simple tool but it's used by the majority of engineers on medium to small size projects. But it's the engineer's responsible for all the input, like how long a beam is, what's the load of the beam, and what's the depth of it, and it just helps you to like pick which specific members you're going to use. Yep. Recently, yep. Um, no, they're both pretty user-friendly tools. For me, the biggest change is just getting used to what you guys, being young, are already used to, is everything is cloud-based, which can be it's good and bad. For me in particular, so that's one of the only drawback I have on either one of them is that because they are cloud-based, certain times they can get bogged down or slowed down depending on when the host company's server might be having a lot of people working on there. That's improved over the last few years. But for me, I know this will sound old-fashioned. I will do a lot of the work still on my desktop and then save it when I'm finished rather than actually working on the cloud-based version of the program. Um, Other than that, no, they're simple but pretty powerful tools. Um, and no, I really don't have any other complaints about either one of them. Mhm. No, it's Reese's pretty much only for I shouldn't say only, but it is geared towards structural engineers. So RISA is a program where you are going in. The best way I can describe it is almost like as if you're going in and doing like a line model. So if there's something, even if it's three-dimensional, it is going to look like a bunch of points, locations in space, and lines going between them, which are going to represent beams or columns or individual members. Um, that's a program that I personally would use to help size structural members. Now to make that more in line with what you're talking from the architectural end, and also from the construction end. A program like Revit, which is a 3D drafting program. Um, you can take some of the you can take some of the information from RISA, and input it into Revit, so they do communicate to each other. But I think what you're talking about more like on your end would be either AutoCAD for two-dimensional drawing or Revit for three-dimensional drawing, and that's pretty common across architects and engineers. And the Revit, I think, is more and more gaining. There's more of an interface between the architects, engineers, and the contractors, using Revit. They do, even yeah, and even Enercalc. Enercalc is not as powerful as a program. It is, but the programmers for that have got to the point to where I think where they've understood there's a need for that, where you can take information from that and start to bring it into the AutoCAD programs or into the Revit programs as well. No, it's been so Enercalc is an old enough program that, you were asked how long I've been doing this, 30 years, and Enercalc has been around that whole time. And really, it started out as nothing more than kind of glorified Excel spreadsheets, and has kind of has morphed over time to become something that's it's more complex, but it's not. There are other tools out there like Rambeam, ETABS. There are other structural engineering. So if you were to do like a high rise building, there would be much more structural modeling that goes along with the calculations, and that would completely interface with Revit. Um, Something like Enercalc, where you're just kind of running individual pieces, like the programs can communicate, but they're not completely interlocked like some of the other more powerful programs. So it is, yeah, it is something that I think in the last 5 years, I think most of these programs have started to understand that, they need to be able to communicate with each other so that information can flow easier. Yep, I do. I think, yeah, I think, a little bit of that has to do with what we're talking about as far as the engineering programs, and that what I'm seeing more on what you're talking about is once the information has been used to create working drawings. So once everybody, I'm working in Revit, the architects we're creating a set of construction documents that's shared with the contractor. So in the past, it would just be, a thick set of drawings, actual paper out in a job site trailer. Now those drawings are still out there, but there's also access to the model that everybody works on. And then, the contractor is using that to share, so to communicate with us, so that they can, if there's a conflict on a building, they can pull up the model, say, here's where this problem is. I can look at it and say, okay, structurally, I have a beam there. Mechanical engineer can look at it and go, well, I've got a duct work that wants to run right through your beam. And the architect can look at it and go, well, I can get this to all fit below my ceiling. So everybody can communicate. And if, that's the way it's supposed to work. It doesn't always work that way. That's the way it's supposed to work. Um, yeah, and then the contractors are using a lot of a program like Bluebeam, where they take all that information and everybody again say it's a different way where people can, uh, create, in that way they can kind of mark up my drawings and send things back and forth, communicate that way as well. Yeah, I think so. I think so. It will. It's just, all that stuff takes time, but it's getting there. Yeah.
And then, oh, sorry.
Yep.
Are you guys integrating AI?
We are not.
Okay.
So my firm is relatively small. We're only 9 people. Um, and so not a lot of need for it yet on the types of projects we're doing. talking to other people within the industry, I think you're going to start to see a little bit more of it, but I think what I'm hearing is more on the construction, the contractor's end, and less on the engineer's end right now. Um, there might even be a little bit of a pushback, to be honest, from architects and some of the engineers with the integration of AI. There's going to be some parts of it that everybody's going to want to use to make things more efficient. But I think there's also going to be some protectionism of I don't want AI coming in and designing a whole building for me.
Mm.
Um, but I think on the contractor's end, I think it will definitely be used more in construction management first.
Yeah.
Completely, I could see it helping with schedules, helping with creating shop drawings. Are you guys familiar with what shop drawings are? It's
No.
okay. Okay. So if you're not, so Iman, I'll say real quick what it is. So when we create a set of drawings, like a set of structural drawings, and it has all the information on there of what like a column size is, a beam size is, a base plate for a column, anchor bolts, all these little pieces of information. But the contractors have to take that information and they'll have like a steel fabricator who's going to actually fabricate all that, and
Hmm.
they'll create a set of what are called shop drawings, where every single piece of steel that's going to be in there they're going to have a little drawing for it, and it's going to tell you specifically that that column is 10 foot, 1.5 inches tall. So all the very, very specific information will be within those shop drawings. So that's where I think what I'm hearing is between construction scheduling and helping manage some of that shop drawing procurement is where you're probably going to see AI being used more in construction um, in the upcoming years. I don't know, right? I haven't seen yet from my standpoint how true AI and more so than just like Chat GTB or something like that, but like where like actual AI is going to come in and help yet. But
Yeah.
hopefully I'll be retired by the time it is. I, I, I don't want to lose my job and I don't want to learn anything new. So
Yeah.
hopefully,
Yeah. I feel like it would be nice if AI can be a tool and not a replacement of people, you know?
so and not to, and I'm sorry, I don't want to get too much of your guys' time, but even
Oh,
with the programs we're talking about with the Intercalc or the RISA or any of this stuff from an engineering standpoint, and I know this seems very simple, but it's all of these are tools that are, it's only the output you get out is only as good as the engineer or architect understanding it.
right.
Because I've seen even without AI, engineers put a lot of information into like a 3D model and get back information, and it tells them, oh, these different member sizes will work. And an individual member size might work, but there's more to it than that. Like the way they connect together might not work. So the point to all that is AI might be able to help and think through some of those things that just a typical engineering program doesn't. But it's still going to only be as useful as the engineer who is responsible for the project understands it. So
Yeah.
it might save time in the future, but I think we're a long ways away from AI like doing a full design on a building.
Yeah.
Okay.
Thank you
No,
so much.
did we record today, Abby? All right.
Thankfully.
No problem. No problem. Amon, nice to meet you.
Yeah,
Abby, nice to
nice
meet you.
meeting you.
All right.
Thank you.
Good luck, you guys.
Thanks.
All right. Talk to you later. Bye.
Bye.